Quasicrystals. In 1984, quasicrystals were first observed. These are structures which cannot be indexed to any Bravais lattice and which have symmetries intermediate between a crystal and a liquid. They were first observed in grain size of 2 micrometer in an alloy of aluminum with 14 at PCTA manganese. The smaller manganese atoms are each surrounded by 12 aluminum atoms arranged at the corners of an icosahedron. The structure is made up of parallel icosaedra attracted at their edges. Crystals cannot exhibit the fivefold symmetry of an icosahedron, but a crystal can be constructed by nucleation at a center cell, followed by outward growth from there. All of the space of a nodal cannot be filled by repeating the basic unit. Although the parallel part of the specification does give a long range orientational order to the structure, it is perhaps surprising that the X-ray diffraction pattern of such structure can have fivefold symmetry. That is how they were first observed. The known quasicrystals are intermetallic alloys and very poor electron conductors. They are nearly insulators with a somewhat well defined band gap at a Fermi level. They are of greater interest intellectually in an expanding the definition of crystal lattice. A distinctly different crystal diffraction pattern results from an almost periodic structure, one that is neither rigorously periodic nor simply amorphous. Almost periodic structure can be expressed in one dimension if we are given the electron charge density P of equal to summation of C suffix n cos 2 pi n into 1 plus tau into x divided by a, where tau is an irrotational fraction. The terms of 2 pi n a by themselves give the usual lattice with translation periodicity a. When the terms in pi are added, the charge density is almost periodic. That is, the periodic is not a integral multiple of the period a because tau is irrotational. The period gives a long range non random order to the structure, and the long range order gives a diffraction pattern which appears split off from the pattern defined by the short range order. This is dominated by the reciprocal lattice points in N1 but will appear to be clustered and spread out. The diffraction pattern of a three-dimensional quasicrystal is quite different. However, the pattern is well defined and can have the fivefold symmetry by which quasicrystals were first observed. A computer generated diffraction pattern with fivefold symmetry is shown in picture.